So we're going to do one more integration by parts example. This one is a little bit more difficult. We are still going to be using the tabular method. Oh no, we're not going to be using the tabular method this time. But we do have to integrate more than once. And once you look at this thing at the end, it's kind of actually elegant. But we are going to have to keep the left side of the equation. I know sometimes we'll just throw an equal sign and just not carry it through, but this time we actually need to carry it through. So I'm going to start my integral a little bit lower on the page so I can show my u subbing or my little, my choices for my boxes up high. And yes, I said boxes. So I'm going to reduce what my box looks like a little bit. So I need to pick u, du, dv, and v. And if I do my LIATE, I know that I'm starting with trig is going to win. So I'm going to know that u is going to be cosine x, which means that du is negative sine x dx. The catch here is that we have the exponential and the trig together. So that's going to be why what happens with this one happens. All right, we're going to look at dv. So dv is this e to the 3x dx. I need to integrate that. And we kind of saw in the last one that we kind of have a second u substitution. We have a u sub in there. So that u, or I'm going to call it w in this case, is going to be 3x. So that means dw equals 3dx. But we kind of learned a shortcut for what we would get inside the integral because we know we don't have the 3 in there. So we learned that we could take this to the other side and that will show us what goes in front. So I know when I integrate, I'd get 1/3 e to the 3x. All right, so let's do our uv. So u is going to be cosine x. V is going to be, I've already got it purple, so 1/3 e to the 3x, which I could have put that in front if I had wanted to. And then we're going to go minus the integral of, and it is the v again, so 1/3 e to the 3x. And then the du part, let's go with purple, is negative. I'm going to put the negative out front, sine x dx. So what happened? Well, first of all, I've got double negative is going to go positive. Okay. But look at what happened again. I have another integration by parts because I've got a variable times a variable. So let's do another one. So we've got u equals, again, the trig is going to win. So u is going to be sine x dx, or just sine x, sorry, not dx. And we've got du, dv, and v. So du, if is the derivative of sine x, is cosine x. That means that dv has to be the e to the 3x dx, which we already know is 1/3 e to the 3x. Okay, I'm going to continue to write all this stuff that I had to begin with. So the integral of e to the 3x cosine x dx equals 1/3, I'm going to throw that e to the x up front, e to the 3x cosine x plus, and then this is going to all technically go in parentheses because I have this 1/3 out here that's impacting the whole thing. So from there, we get uv. So u is sine x. Okay, v is 1/3 e to the 3x. And then we're going to subtract the integral of v, which is the 1/3 e to the 3x, and then du, which is cosine x. Oh, and there's a dx missing after that, isn't there? All right, and then of course at the end, oops, we are always going to have that good old plus c at the very end. Technically I haven't finished yet, but just know that it's hanging out there. But I'm really close. So I'm going to distribute that 1/3 in, and then I'm going to show you something really interesting about this. So we've got the integral of e to the 3x, because it looks like I'm just going to keep cycling, right? But there's something interesting that's happening right now. E to the 3x cosine x plus it would be 1/9 sine x e to the 3x minus 1/9, because I'm distributing that in, e to the 3x cosine x. Got the integral in there still, dx, and then technically plus c. So I want you to look at this and this. Other than the coefficient in front, those are like terms. And we know with like terms, we can combine them together. So I'm going to combine them together, but I need the coefficient in front. So I'm going to write the coefficient here as 9/9. So I'm going to add this to the other side. So 9/9 plus 1/9 would be 10/9. The integral of e to the 3x cosine x dx equals 1/3 e to the 3x cosine x plus 1/9 sine x e to the x 3x. I guess I could put that in front, plus c. Now, in order to figure out what this equals, which is ultimately what our goal was, all I have to do is take this 10/9 and move it to the other side by multiplying by the reciprocal. So we know that e to the 3x cosine x dx is equal to 9/10 times 1/3 e to the 3x cosine x plus 1/9. I'm just going to reverse it now. E to the 3x sine x plus c. Isn't that beautiful?